Hello to everyone. Today's topic is about trigonometric function by integration. To those students who enrolled in calculus, especially integral calculus, this semester, join with me to study this kind of problem. So I have here integral of tangent to the fifth theta d theta. So the first method that I will introduce to you is I have to split this one. So I will break this one as integral of tangent to the fourth theta, then tangent times tangent theta. So if we multiply this one, that will come up with tangent to the fifth theta. Okay? And recall our identity. The Pythagorean identity, we have 1 plus tangent squared theta is equals to secant squared theta. Okay, solving for tangent squared theta will be equal to secant squared theta minus 1. So again, I have to break this one. So this will be integral of tangent squared theta squared times tangent theta d theta. Okay? Then I will plug in the value of tangent squared theta, which is secant squared theta minus 1. So this will be circle brackets secant squared theta minus 1 squared. And then multiplied by tangent theta d theta. Okay? I will expand this one. So secant squared theta minus 1, then multiplied again by itself. So this will be secant squared theta times secant squared. That will be secant to the fourth theta. Then multiply secant squared theta times negative 1. That will be negative secant squared theta. Then multiply, that will be negative secant squared theta. Then negative, that will be positive. 1 times 1 is 1. So bring down secant to the fourth theta, negative secant squared theta, then minus secant squared theta, that will be 2 secant squared theta plus 1. Okay? So again, I have to plug in this one. This is the expansion of secant squared theta minus 1. So this will be integral of secant to the fourth theta, then minus 2 secant squared theta, then plus 1. Then I have to write circle brackets and then multiplied by tangent theta d theta. Okay, so I have to multiply 1 by 1. So this will be integral of secant to the fourth theta times tangent theta. Then this will be minus 2 secant squared theta times tangent theta. Then the last will be plus tangent theta times 1. That will be tangent theta d theta. Okay, so I have to integrate individually. So this will be integral of secant to the fourth theta tangent theta d theta. Okay, then this will be, since this is constant, so I have to place outside of the integration symbol. So this will be 2 integral of secant squared theta times tangent theta d theta. Then the last one is integral of tangent theta d theta. Okay, then I have to split this one. So I have now integral of secant cube theta. Then the other one will be secant theta tangent theta d theta. Okay? Because if I will multiply secant cube theta times secant theta, that will come up with secant to the fourth theta. Okay? Then this will be minus 2 integral of secant squared theta tangent theta d theta plus, just writing here, integral of tangent theta d theta. Okay? Allow me to erase in this part. And this one also. So I have integral of, I'll just transfer here, secant cube theta, secant theta, tangent theta d theta, then minus 2 integral of secant squared theta times tangent theta d theta, and then the last will be plus integral of tangent theta d theta. Allow me to erase this one. Okay, so u will be secant theta, so du will be derivative of secant theta will be secant theta times tangent theta d theta. So this one will be du. So I have now secant cube, so meaning u cube. Then secant theta times tangent theta d theta, that will be du. Then how about the second one? So minus 2. So in here also u will be tangent theta. Derivative of tangent, that will be secant squared theta d theta. So meaning secant squared theta d theta is equivalent to du. So meaning negative 2 integral of u. Then secant squared d theta, that will be du. Then plus integral of tangent theta d theta. And we know that from our formula, tangent theta d theta will be equal to, or tangent u, we will just replace u. U du is equals to negative ln absolute cosine u plus c. Okay? So, integrate. So, this will be u to the fourth over 4. Then minus 2 integral of u du, that will be u squared over 2. Then plus. Okay? So, the formula of tangent, integral tangent u du is equals to negative ln absolute cosine u. Because from the derivation, this will be secant, sine u, then cosine u, du. Okay? So, of course, u will be cosine u. Okay. Just replace x. So, be x. Okay? X. So, this will be, so, du will be derivative of cosine, that will be negative sine x dx. Then divide by negative 1 both sides. So negative will be crossed out. So I have now negative du is equals to sine x dx. Okay? So meaning, this one will be sine x will be integral of negative du. Then cosine will be u. Okay? Sine x dx, that will be negative du. So meaning this will be negative. And we know that integral of du over u is equals to ln absolute u plus c. Because this is indefinite integral. So this will be negative ln absolute u. U is cosine x plus c. Okay? So just write in here. So just to make it clear. So this will be negative ln absolute cosine x plus c. That's how to derive this formula. So I have now negative ln absolute cosine theta, because this is in terms of theta. Then this will be plus c. Then simplify 1 over 4. Then this will be u to the fourth. This will be crossed out. So u squared, negative times positive, that will be negative. So ln absolute cosine theta plus c. Okay, so plug in the value of u. 1 over 4. U is secant theta to the fourth. Then minus circle brackets, tangent, this part, tangent theta squared, then minus ln, absolute cosine theta plus c. Okay, to simplify, my final answer will be 1 over 4, second to the fourth, theta, then minus tangent squared theta, then minus ln, absolute cosine theta plus c. This is now my final answer. That's all. A friendly reminder, if you have questions regarding to my discussion, you may write your comment or comments at the comment section. Then if you agree with me, please like and share. And do not forget to subscribe to my YouTube channel, Franz Maths TV. Thanks for watching.